Math 1332, Chapter 2, Set Theory, Section 3, Using Venn Diagrams to Study Set Operations, Video 2, Drawing a two-set Venn diagram to represent a set operation. All right, for this video and the three examples it contains, we're simply going to figure out what part of a Venn diagram do we shade in to represent a set operation. You'll notice we've already got a generic two-circle Venn diagram drawn here with sets A and B, and the regions labeled as 1, 2, 3, and 4, which will be our standard numbering for the regions in a two-set Venn diagram. So how do we figure out what to shade? Well, there's a couple of ways to do this. One of them is verbally, and the other one is algorithmically. Now, if you're not familiar with the word algorithm, an algorithm is just a sequence of steps that you follow to produce a result. A recipe is an algorithm, for example. In mathematics, an algorithm is usually a process that takes us from the beginning of a problem to the end of a problem. The advantage to doing these Venn diagrams algorithmically instead of verbally is that there are no decisions to make. There's no intuition you have to play into it. Now, that being said, I challenge you to take what you know about Venn diagrams and set operations and see if you can anticipate what we're going to shade in. For example, on this one, we want the complement of A union B. Do you know what A union B looks like in the Venn diagram? What we were to shade in? And do you know what the complement means to do to a shape in a Venn diagram in terms of shading? If you can verbally walk through that or mentally walk through that, you might already know what region or regions to shade. But I don't want you to have to guess at it. I want you to be able to follow a predetermined set of steps and then get the results that are desired. So how do we figure out what regions to shade in? Well, we do the following steps. First, use set operations. First, define the sets in terms of their regions, which is what we did on the follow-up video to video 1. So for this one, our sets are A, which is made up of regions 1 and 2, and B, which is made up of regions 2 and 3. Technically, you should also think about the universe, but you can just think about the universe because it's always going to be all the regions in play, which in this case is 1, 2, 3, and 4. But that's your first move, is to define the sets in terms of their regions. And really, it's just a matter of looking at the picture and saying which numbers are in which sets, All right, step 2. Using the order of set operations, turn off the caps lock. Using the order of set operations, determine the elements of the desired set by using the results from step 1. All right, so what does that mean? Well, what that means is we're about to do what we did in the previous section, where we try to figure out the contents of this set. I didn't mean to erase. Let's try that again. We want to find the contents of this set based on the contents of these sets. So this is where you actually have to do the work. But if you've done the previous videos, then this work is pretty straightforward. And just a reminder how we do that. We want to find A union B, the complement of A union B, and we have a particular order in which to do that. I'm not going to rewrite the order of set operations, but parentheses is first, and inside the parentheses we have a union, so we're going to do this union first. And then that concludes the contents of the parentheses, so those are the only operations in the parentheses, and so we would go outside the parentheses and we would do the complement second. So first we need to figure out A union B based on these determinations in step 1. Union just means combine the two sets. A consists of regions 1 and 2, B consists of regions 2 and 3. So if we take the union of those, we get 1, 2, and 3. And then our second step is to find the complement of that. Well, complement means which elements in the universe are outside of that set. So it might help to look at the universe and cross out the elements of A union B, since we're looking outside of that set. And the only thing that remains is the set containing region 4. So what does that mean? That means two things. In terms of regions, the set we're looking for consists of region 4 only. But what it also means is that we're ready to finish the problem. Your third and final step is shade in the regions determined in step 2. So basically, we're just doing the same type of problem we did before, but with specific elements for our sets, namely elements that represent regions. And at the end, it will tell us what regions to shade in. So the answer to the question, I think I just undid something. There we go. The answer to the question that we're looking for, which regions, draw a Venn diagram for the following set operation. And I'm not sure if I actually said this at the beginning, but what they're asking us to do is to shade in the appropriate regions. And that my stylus jumped off the screen. That appropriate region would be region 4. Now do me a favor, if you're going to shade in region 4, make a concerted effort. And I'll show you what I mean by an unconcerted effort. It didn't have to be completely filled in, but I would rather have something like that than like that. That's just a cop-out. I'm literally asking you to color. So just put a little effort into it, especially if it's out here, because this is where most of the space is. Just put a little effort into it. Doesn't have to be completely filled in, but try real careful not to spill into the regions that you don't want. I think that's good. All right, so yes, these questions are asking you to color. All right, let's take a look at another one. Draw a Venn diagram. Oh, excuse me. We'll do that one in a second. At the beginning of this one, I challenge you to think about this one verbally. And it is possible to know to shade this portion of the Venn diagram without doing any of these steps over here. It's not always easy, but it's possible. In this case, you would think, well, A union B, that's just the two circles together. And then the complement would be everything outside of that. So there is a way to verbally and mentally process some of these to the point where you would know instantly what to shade. And you have to forgive me, I thought I already had a two-circle Venn diagram set up here. So let's just say the magic words, alakazam, and poof. Here's our Venn diagram, complete with the regions that each set is comprised of. All right, so let's see if we can figure out what A intersect B complement is. And again, I challenge you to try to mentally process what you would shade in here by asking yourself, what does intersection mean? What does complement mean? And it's not impossible. In fact, just looking at it for a second, I know exactly what part of this Venn diagram I'm going to shade in. But I don't want you to have to just guess at it. So let's actually build the answer. All right. So to build this answer, we're going to start by figuring out the correct order in which to build this set. Now, granted, step 1 is already done because we made the recognitions up here of what regions comprise the universe set A and set B. But if we want to figure out A intersect B complement, we have to determine the correct order in which to do it. There are no parentheses. So our next operation in the list of, in the order of set operations is complement. So we're going to do B complement first, and then the only remaining operation after that is the intersection. So let's start with B complement. B complement is all the regions outside of circle B. Outside of circle B is regions 1 and 4. Our second move is to find an intersection. We are looking for the intersection of A and B complement, just to make sure we know exactly where we're looking. Set A is right here. Set B complement is here. And we want their intersection. So, looking at those two highlighted sets, do they have anything in common? Yes, they both have the Roman numeral 1. And so now we know exactly where to shade because we were looking for precisely A intersect B complement. And according to this, we would shade region 1. So let's shade region 1. And again, it doesn't have to be a perfect shading, but put a little effort into it. Is that the region you were thinking earlier? I was, but then again, I've had a lot of practice. Ooh, this one looks difficult. Well, it's not really that difficult because it only has 3 set operations instead of 2. And just like before, I forgot to put the 2-circle Venn diagram in advance. So just close your eyes for a second and then it'll suddenly appear. And there we go. All right, let's start by analyzing our set expression and figuring out the order in which we're going to build it. We have 2 sets of parentheses, and so we go left to right. And inside the first parentheses is only the single set difference. So we will do that first. 1 second. Okay. Then we got another parentheses. So we'll do that set difference second. That completes both parentheses, and outside is a union, so we'll do that union third. Now that we've established the order in which we're going to build this expression, let's build it, starting with a minus b. All right, remember how set difference works. Set difference works by taking the first set, which is right here. So let's write that one down first. Set A contains 1 and 2. And then from that, removing anything that happens to be in the second set. Well, the second set is set B, which contains regions 2 and 3. So from our first set, we need to remove region 2 or region 3 if either one is present. Region 2 is present. We've just taken away set B, and that leaves us with just region 1. Now, some of you might have been thinking, I remember what you said in the previous video, region 1 did represent A minus B. That was supposed to be a highlight. Region 1 did represent A minus B. So why did I reinvent the wheel? Because you may or may not have remembered that. But if you remember that A minus B was region 1, that's great. Then that's less work you have to do here. You still need to build your expression, but how you build it depends upon what you know and what you don't know. Our second set operation that we're going to build on is the second set difference, B minus A, and we'll walk through this one a little bit faster. Set B contains regions 2 and 3. You might be wondering how come sometimes on my Roman numerals I draw the horizontal lines on top and bottom, and sometimes I don't. Honestly, don't know. Just a left brain, right brain struggle, I guess. But for B minus A, we start with set B, which contains regions 2 and 3. And then from that, we cross out anything that also belongs to set A. Set A containing regions 1 and 2 means I would cross out region 2, and that would leave me just region 3. And then for our third and final step, we're going to take the union of the previous 2 results. Union of A minus B and B minus A. Well, that's pretty easy because all union says we have to do is join these 2 sets together. And if we join them together, we get regions 1 and 3. And since that's our final result, then this, it's supposed to be yellow, but I'll take it, is the region, or excuse me, regions that we want to shade. Region is supposed to be a highlight. Region 1. Skip there, but that's okay. And region 3. So whenever you're doing a Venn diagram for a two-set Venn diagram for a set operation, it's really just a follow-up to things that we've done previously. The previous stuff that we did was determining the correct order in which to build the expression and then doing that order. The only difference here and previously is that our sets represent regions in a Venn diagram, and when we get to the end, it tells us exactly which regions we need to shade. In the next video, we're going to do the same thing, but we're going to do it for a 3-set Venn diagram.